Hi, it's Carly McAvoy. I'm talking about line of best fit or least squares, regression line, or sometimes just a regression line. And there's a lot of information on this graphic, so let's get to it. So I'm looking at a scatter plot that has cigarettes per day on the x-axis. That would be our independent variable or our explanatory variable. And then we have life expectancy in years on the y-axis, which would be our dependent variable, or also response variable. And all these circles or points on our graph are data points. And so when I talk about the actual data value, that comes from the data set. So for instance, this data value right here, if I look down here, it looks like it's about somebody who smokes 8 cigarettes a day has a life expectancy of about 84. So that's what that means. I could write an ordered pair for each of those points. And that's something that I was given, and then I put into this graph. Now, each of these points, I drew a little line down to the regression line. This is the regression line here, the red line. And the regression line is the best fit, the line that kind of gets the closest to as many points as possible. And I drew a line down because this line, the distance from the actual point to its predicted point on the line, is called the residual. So all you have to do is just subtract the actual value minus the residual value to find the residual for each of these points. Now, we call the actual value y and the predicted value y hat. That's drawn terribly, and I apologize for that in advance. So we know that if we have something, a residual point that's above the regression line, then all of these points have positive residuals. Because if you take a larger number and subtract a smaller number, you're going to get a positive, right? So that just means that for these points above the line, the model has underestimated the y value. So for instance, here it looks like the actual value is somewhere around 92.5, but if I drop down to the line and the predicted value is something like 84. So obviously they underestimated here. Anything above the line has a positive residual, and that value has been underestimated. On the other side of that, all points below the regression line are negative because the actual y value is less than the predicted y value. So if I'm thinking that it's going to be 80 and then it's predicted to be 82, well then 80 minus 82 would definitely give us a negative number. So these are all negative residuals down here. And what that means is that the model overestimated that y value in this case. So the residual here, the largest residual here looks like this one. The data value that's the furthest from the line has the largest residual. And if that value were moved closer to the line, to the prediction that's on the line, it would strengthen the association. So if we had a line where all of our points were really close, then that would be a stronger association. And if they're further apart, then that's a weaker association. And so we can tell from this one that we don't even have any points that are on the line, which would give us a residual of 0, right? So when we're looking at this line, it has a slope. You can tell that it goes down from left to right, so it's a negative slope. And the equation was given here. This is using GeoGebra, and they gave us the negative 0.63. That's the slope. But notice what the R is. The correlation coefficient is negative 0.7134. That's different. So I just want you to remember that the correlation coefficient is not the same as the slope. They're not just one and the same. This is not the same. So if you're wondering why I put it in there, just because I wanted you to see that, because the stronger the correlation, the closer the correlation coefficient comes to 1 or negative 1. And so when we have it at 0.74, it's pretty strong, but it would be perfectly strong if we could get it all the way to negative 1. And then when we take that value, to the second power, then we get the coefficient of determination. And that indicates the level of variation in the given data set and tells us the percentage of the points that would fall within that regression line. So we have less than, just barely half, right, of our points kind of are predicted by that. So it's not a great thing, but I just want you to remember the slope and the line, the slope of the line and R are not the same thing. That y hat is the prediction and just y is the actual value. And I don't think there's anything else I need to say at this time. This is a lot of information to put together in one thing, but I think it's valuable to be able to refer back to this in your notes. Have a good day.